Hi, I'm Dr. Chapel. I'm Water Resiliency Specialist in Bio and Ag Engineering at North Carolina State University.
Hey, Max Knowles. I'm a livestock agent with Cooperative Extension in Sampson County. In today's video, we've got some stuff to show you here. First off, we have an irrigation gun here. This is a Nelson 100 big gun, an SR 100. They come in different sizes, 75 all the way up to 200. We have the 100 here. Most commonly here in southeastern North Carolina, I usually see the Nelson 150. So when talking about this Nelson 100, we'll kind of go over a few of the components. One of the first things is the drive vane here at the front. So when you're doing your regular irrigation, as this drive arm assembly goes back and forth, this drive vane actually helps turn the head of the irrigation head consistently. So as it goes around, it hits this trip lever assembly. So you set these here, and every time it trips, it'll slightly and it will change direction of the irrigation head itself. So here on the side are the reverse stops. So by setting these, you can actually change or modify how many degrees your irrigation head is turning. These work great. If you kind of keep it on the same degree of throw every time, you want to make sure to keep these serviced. I would suggest keeping them sprayed, maybe some anti-seize, but they're great. These weights right here for this actual arm, they can be adjusted forward and backwards for slower or faster of the drive arm itself. So one other thing to think about, we've got a couple different nozzles here. We've got a ring nozzle here, which we'll show, but we wanted to touch, Dr. Poole's going to talk a little bit about a phone app that you can actually get the pressure on a phone app in real time. If you don't have that, you can actually do it manually in the field. The pitot tube, is a pressure gauge. While it's operational, you can stick that in the front and actually get your reading of pressure in real time manually.
So he was able to touch on how we check the pressure when we're in operation with a pitot tube. There's another way we can do that also in this gun. There is the actual port here where you can screw in a regular pressure gauge that does not have the pitot tube attachment in an elbow on that port, and you can read the pressure directly that's coming out of that gun from that port. So the new technology that's come out that's really made things a lot nicer for calibration in the field is this unit right here. This is actually a pressure transducer that is Bluetooth enabled. So as long as you filter the effluent going into that pressure transducer to protect it, you can log into this with a cell phone, which I have here from an app that's available online. That app is actually costing one-time fee of $4.99. You can log into this pressure off transducer here, and while you're doing an in-field calibration of wetted diameter, you can read the pressure that's on that gun instantaneously without actually having to get up on the implement to read that pressure. So it's a really handy tool to keep you out of the waste stream to make sure you're getting operating pressure when you're looking at wetted diameter calibrations.
Okay, so we've talked a little bit about the Nelson 100, getting pressure at the end of the gun at the nozzle itself. We've got a few example nozzles here we would love to show you. So we have a tapered bore nozzle here. That is a set diameter on that one. There's also a taper ring nozzle, and then we have a ring nozzle set here. So this is a ring nozzle set. So you can just simply remove it here. We have 7 different rings here as well, from 0.71 to 0.96 as well. This ring set already has it labeled, but if you're in the field and it's not labeled, you can actually measure it. So I've got a micrometer here, and this is a 0.96, so we will measure it and see what we have. And it's 0.96, perfect. So that's a way that in the field you can actually measure it. This is a digital one. We have a nice digital one here that's actually 3 decimal places, and we have a manual one here as well.
So we want to tag team what goes in to determine application rate in the field before we go into the details of the gun here. And there's basically 3 fundamental things that we need to have. The pressure at the gun itself, the flow rate coming out, which is controlled by the nozzle size and the pump pressure combination, and then the forward speed or the pulling in speed of the traveling gun or the reel.
Yep, and when talking about wetted diameter for the irrigation gun itself, you can either use a roller wheel for measuring that. You can also use a tape. You can use the pitot tube for pressure at the gun. And then we've also got the phone app as well. We've got flow meters at the extension office if you would like to actually get the gallons per minute that's going through the pipe. So that's some ways that we use this equipment to calibrate it. Here in North Carolina, permitted hog facilities have to get an irrigation calibration at least once every other year. So that is a requirement of their permit.
So in talking about setting those flow rates, once you're able to determine the pressure and all, what you first need to do is figure out the application depth that you want to put out on the field. And then you need to go to the manufacturer charts, which we have here for the particular nozzle size that you have, the operating pressure, and the desired gallons per minute at the travel speed that traveler is going to be coming in at. So you can basically determine the wetted diameter of that, which ultimately will give us the actual application rate in the field. So it's kind of a combination of factors that we're going to discuss in this video.
So we've shown with the calipers how you can measure the actual diameter of the ring itself. So it's important to understand that if you have a larger diameter ring nozzle, that will change your application gallons per minute. So for your record keeping and farm operation and yields on your fields, it's important to understand that. So we've got a 0.71 all the way up to a 0.96. That might not seem like a big difference, but going to our manufacturer's chart for Nelson, let's look at 40 psi for the ring nozzle at a 24-degree trajectory. That's a big difference in gallons per minute. So 0.71, you're looking at only 66 gallons per minute. But if you go to the 0.96, you're actually looking at 152 gallons per minute. So that's quite a difference. So it's important to know what ring nozzle we have in our gun. So we've been talking about Nelson guns, the 100 series we have here today, from 75 all the way up to 200. We've got a taper bore nozzle. They have taper ring nozzles as well. Nelson does make plastic actual nozzles that go on the end. So when we're looking at Nelson guns, Nelson nozzles, we want to use their manufacturer sheets. But it's important to know there are other manufacturers. So right here we've got just a single nozzle example of a Comet. So it's important to know if I'm looking at a Comet nozzle, we want to make sure to use their manufacturer's charts for that application. So we're talking about different nozzles. The taper bore nozzle itself, it's considered the standard nozzle. It usually has the least amount of stream diffusion, usually largest gallons per minute and wetted diameter. Now the ring nozzle itself, it provides the flexibility to change your actual nozzles. It has the largest amount of stream diffusion, but it's important to know if you do change your nozzle size, it's going to change the operation of your irrigation system. So if you have a calibration with a 0.71 nozzle and you change it, it's important that you, the farmer, you, the agent, a technical specialist, does an updated calibration to know what you're putting out in your field.
So we were just discussing how to measure these rings. When you're thinking about maintenance of these pieces of application equipment over time, one of the things that typically wears out first is the ring, because we're putting effluent through there. Sometimes it has particles in it and it will cause a wear edge on this ring. It can get bigger or smaller. That actually affects the uniformity in the field. So it's important, at least a yearly evaluation, that you come out and use that micrometer to measure these rings to make sure that we can stay in where we need to be for a uniformity in the field itself. Some of the other points, again, having those pressure readings, not only is that important for calibration, but it also gives us an indication of whether we have other problems within our pumping system. For example, if the pressures are low and we can't get to where we were on our first design specs, there's a good chance that we have wear in the impeller or in the pump itself. So that gives you an idea of things that you need to check in your irrigation system before you get into the next application season.